So, hello, good afternoon. Welcome from Fronius. We are very pleased to show you today our new webinar. The topic is high power modules, more than 13 amps, combined with Fronius inverters. We are here together from Fronius. My name is Hans Pelz. I'm doing this presentation about 25 minutes. And beside me is also Christoph Schillinger from also from the trainings team, and he will answer your questions, which you can send us, please, during this presentation. So feel free to send us your questions. What would I like to show you today is what are the high power modules, what are the differences, basically what you need to take into consideration when you connect them to a Fronius inverter, and what losses can you expect when you connect them to a Fronius inverter. Basically, first of all, what are these PV module trends now? So their power is increasing. You know, we're going to higher than 400 watt, up to 500 watt power classes nowadays. The cell sizes is increasing with that modules, so to 10-inch or 12-inch, and the module current increases as well, up to more than 12 amps, so up to the 18 amps basically at the moment. And these modules will be offered at the moment from Trina, Jinko, Yasolar, and Longi, and some others. But basically, we'll see that more and more manufacturers will ship those new modules. How can you find out which modules is it? Basically, we differentiate between type A and type B, or type A the 10-inch and type B the 10-inch, the 12-inch cells, where the PV power is on the type A around 400 watt peak, and with the MPP power current from around 12 or 13 amps. The size of the modules is about 10 centimeter wider and 5 centimeter longer, so 110 times 175 centimeters. These modules are really important because they will be used in all segments in the future, basically as well in the residential systems. The other one, the type B modules, will be mainly used for free field installations, and they have a quite high power as well, which is around the 18 amps, coming with the also quite big size of 120 times 230 centimeters, so really big one, also heavy ones, and usually not be used on a rooftop installation. So basically, maybe there are some countries where you will also do that in the future, but at the moment in Austria, Germany, nobody will use this in modules because of the big size, which is of course difficult for the handling on the roof. So we will concentrate in this presentation as well on the type A modules, but also a short information on type B modules. So, and before I now continue with the combination with Fronius inverters, I would like to have a short question to you. If you could maybe answer this question now. The question is, are you already using high power modules? Answer is yes, as much as possible, yes, but only if needed, not so far. Or you can also choose two answers here, yes, but also in combination with Fronius already. So if you have already experience with combination with Fronius inverters. So great, I see already 60% feedback. Guess I'll wait another, please select, give you another few seconds time to answer. Good, now we have 65%, that's fine. Thank you so far. I'll just give you the answer. If I will share that with you, that most of you not too much experience or not using the modules that often. A few as much as possible, 18%, and also 18% using in combination with Fronius inverter. Great. Thank you very much for that. And now I would like to continue with my presentation. When you combine these modules with Fronius, you have to, first of all, or in general also with other inverters, of course, first of all, double check the module data from the short circuit current. And we also need the maximum current per string or per connection on the inverter. So of course, if that connection is strong enough to cover this current, short circuit current of the module, then you can do that, of course. If not, you have the possibility to use a pre-combined solution. That means you connect the modules on two different inputs of the inverter. If the direct connection is not, if the short circuit current is higher than the input and you have no other possibilities, then it's difficult to connect them. So that's the first approach. The second approach is to double check the maximum input current from the MPP tracker and compare that with the maximum of MPP current from the module. So if you are also below that, or if the maximum MPP is higher than the maximum of the module, there's no derating. If no, then some derating is possible. So make sure that you have here the right MPP tracker power or current to cover this module current. Now we'll have a little bit closer look how in a practical example, we have here the Gen 24 inverter 10 kilowatt, and on these Vago clamps on the DC input, we have a maximum current per connection of 25 amps. So when I connect this Jinko module, for example, 400 watt with this 13.73 short circuit current, then of course there is no problem because I'm below these 25 amps. So no worry, you can connect these modules on the Gen 24 inverters. So the Vago clamps are strong enough to cover this current. On the other hand, if you use snap inverters, the SIMO 5, for example, snap inverter, so the older generation, then we have a maximum input current per screw terminal of 33 amps. That means also fine, no problem. Here we have still enough space to cover this current on the screw terminal. So first thing is fine, no problem. There's just one exception now. Basically, this is when you use string combiners on the roof. So you have two strings on the roof. You combine that with a string combiner on the roof, and then you go with one cable down to the inverter. And then you have these 2 times 13 amps, or in this case, 13.7 amps. That means we are higher than 25 amps. And then it's not allowed to connect these high current on the Vago clamps because the Vago clamps are not made for this high current. Therefore, the only way is to get 2 cables down from the modules to the inverter, of course. So this is actually the only exception from the short circuit current issue. So if you do a combination, combining different strings on the roof The other thing is the comparison of the MPP tracker current. So I compare here the usable MPP input current, which is on the Gen 24 plus 25 amps for MPP tracker 1 and 12.5 amps for MPP tracker 2. So when I look at the MPP current of the module, which is 13 amps, 13.05 amps, this is slightly higher than the 12.5 amps. So if I connect this to the second string on the second MPP tracker, I will have small, very little derating. And when I do it on the primer, for example, snap inverter 5.0, there is an input of the MPP tracker of 12 amps. That means here we have a bit more than 1 amp higher current of the module. That means also here we can expect a small derating. And now let's have a look. So, but you can do that, of course. So there's no worry. That's fine. It's just a derating issue. When you have a look, we did also a study here in different countries. This one was also from Australia. So with very high irradiation, with 2 strings of 13 amp modules, and we connected them on these 2 MPP trackers. So each string on 1 MPP tracker. As we have seen before, we have this limitation with 12 amps or 12.5 amps. On the primer, we have actually 12 amps. That means on the Gen 24 Plus that we have over dimensioning of about 8.3% with these 13 amps. And we have calculated the yield losses over a year, and we got as a result a 0.2% lower yield. So yield losses with this in this range. So basically, not a real big problem. I guess this is so low that nobody will recognize. On the Gen SIMO inverter, it was even less because on the SIMO we have 12.5 amps, so it was here 0.1% only. We can also see here the different yield losses over the irradiation. So when you see here the days here, how many days we have with these different irradiation, then we can see that with the 950 up to 1050 watt per square meter irradiation, we have got here this around 0.2% yield losses. So only on the very sunny days and sunny in the sunny period, we have got these losses. So that's with the 80%, it's really very, very low. So don't worry about that. We've tested also more. We doubled this up to 15% higher power or current. And even with that, we have achieved below 1% energy loss over the year. So I think this number can be used when you are 15% over the MPP input current, then yeah, you will be able to use it without any big issue. Customer will not really have a lower energy yield. So then you can easily do it. If it's more than 50%, then of course it's probably not the best to do it. So when we now go to the different inverters, we see that on the Primo, on the snap inverters, and also on SIMO, you can easily connect the modules because the string connection can handle these 13 amps easily, and also on the MPP current, we see that there is no limitation, only with the Primus 3 to 5, where we have this 12 amps. Here you will expect a little derating of this 0.2% roughly. What you could do here is, if you have two strings, for example, you could, or if you have this higher current, you could put in a jumper between DC1 plus and DC2 plus, and then you share the current on two MVP trackers. So basically, with that solution, you would have no derating at all. So, but I think for this really very little derating, it makes no sense. If the derating would be higher, then this is of course recommended. Just put in a bridge between the two MPP trackers when you have only one string, and connect them on two inputs. So it need not to be two strings, as we shown here in the picture. It can be, let's say, it's one string. You have a module with 14 amp MPP current, and then you connect that on DC1 and on DC2, so on both inputs, and then you have no derating. So now let's come to the snap inverter, to the bigger ones, where we also would like to probably use the 18 amp modules. As you can see here, there is no limitation on the maximum short circuit current. Just on the Eco, we have a 15 amp maximum per screw terminal. That means here, if you use the 18 amp module, this is not allowed to do. So in this case, you need to use here the string connector kit. This can be also bought from Fronius. It's more or less a parallel connection of all the input screw terminals, and with that, of course, you can use that as well. On the MPP current, we see that we have a little limitation on the SIMO 10 and 12.5. When you're using 18 amp module, you will be here as well about 10% roughly around higher MPP current, and you will have, of course, a little derating here expected when you do so. But all in all, I would say no problem. Only take care with the Eco inverter, the string connection. If you use 18 amp module, use the DC connector kit. Now let's come to the consequences for the Gen 24 inverters. And you can see here as well that there is low derating expected because of the 12 amp input on the Primo and SIMO small ones. As on the SIMO 6 to 10, also a very little derating, which is 0.1% only. So here, I would say as well, that's fine, no problem. You can use that easily. And then last but not least, the Tauro inverters, the new big commercial inverters, 50 and 100 kilowatt. There are two versions available, the direct version and the pre-combined version. On the pre-combined version, there are no limitation even with the 18 amp modules. So you can use both modules on the pre-combined. On the Tauro D version with the 18 amp modules, you would have some, of course, problems, because we can have a maximum short circuit current per string, per connection of the MC4 plugs of 14.5 amps. That means that here we have a small, we have a limitation, of course, we have a higher derating here. And with that, of course, 14.5 to 18 amps, that's quite a lot. So I would, of course, would not do that. In this case, please use the pre-combined version of the Tauro for the 18 amp module. For the 13 amp module, everything is fine, no problem at all. What you should take care when you connect the Tauro to, let's say, 15 strings on the Tauro Eco 100, that you share the input per input range, because we have here three separate parts on the input of the Tauro, where you should connect 5 each to each PV array here on the inverter. So basically, or for the Tauro 50, we have 2 different, and then share the 4 on both inputs. Don't put 8 or 7 on the first one and 1 on the second one. So this is here just important that you have on both inputs roughly about the same number of strings. Yeah, then with our solar configurator tool, you can calculate this. We've also updated the solar software, has been released. When you do a configuration with Simochain, for example, you will see now that this is possible with the 13 amp module as well. And on the right-hand picture, you can see as well with the, for example, Primo snap inverter 50, that there's a recommendation, you can see down below, PV1 and 2 connected together and a string with 1 string of 13 modules. So you put in the bridge here between PV1 and 2, so input 1 and 2, and then you have no derating as well. So that's all shown in the configurator. The configurator, if you use that, it's safe for you. You are on the safe side when you use this configuration, which are shown here on the configurator. So we take this into consideration, what I've told you before. Good. Now, last but not least, the summary. Basically, first of all, our residential inverters can easily be combined with all 13 amp modules, minor energy losses in some cases, let's say with these especially Primo small ones, where you have small derating, which is basically below 0.2%. On the commercial side, snap inverters can deal very well with all these modules. The Eco snap inverter, take care, use the DC connector kit when you use the 18 amp modules. On the Tauro, use the Tauro P for every module, or the Tauro D, but then only for the 13 amp module. Basically here you see the summary again, what you need to take care when you do so. Good. That's it for the moment. We will send you the recording tomorrow. We will also have included a white paper about these yield analysis with a higher MPP current with some derating, and we'll also continue with webinars and online trainings. We have a special system design with Fronius products training, online training, where we go also here. We also inform you about these new modules in the future. Other information can be found on our webpage under downloads, solar energy. Feel free to use here the data, available data. Good. Then I would say I will have a look to your questions, and so far I haven't seen any question. I would say we will stay with you. Feel free to use the next 10 minutes to send us your questions. We will answer them immediately, and for that point of view, we'll thank you for your participation and wish you a good afternoon, a good evening. Enjoy your time, and hopefully see you soon again at one of our next webinars. Thank you very much. Goodbye.